Now chapter 3 exercise numericals. 3.1 State for each of the following physical quantities if it is a scalar or vector. Volume, mass, speed, acceleration, density, number of moles, velocity, angular frequency, displacement, angular velocity. So now see here, the physical quantities given to you are volume. So volume, that is scalar quantity, then mass, scalar quantity, speed, scalar quantity, acceleration, vector quantity, density, scalar quantity, number of moles, that is simple number, so scalar quantity, velocity, that is vector quantity, angular frequency, again scalar quantity, displacement, that is again vector quantity, then angular velocity, that is also a vector quantity. So here scalars are volume, mass, speed, density, number of moles and angular frequency, and vectors are acceleration, velocity, displacement and angular velocity. Clear? Now 3.2 Pick out the two scalar quantities in the following list: force, angular momentum, work, current, linear momentum, electric field, average velocity, magnetic moment, reaction as per Newton's third law, and relative velocity. So here we have to pick out two scalar quantities, right? So see, the quantities given to you are force, angular momentum, then work. Yes, work, that is a scalar quantity. Then current. Yes, current, that is also a scalar quantity. And all other quantities are vector quantities. So here answer is work and current. Now 3.3 Pick out the only vector quantity in the following list: temperature, pressure, impulse, time, power, total path length, energy, gravitational potential, coefficient of friction and charge. So here say we have to pick out only vector quantity. Okay. So see here, temperature, pressure, impulse. Yes, this impulse, in future we will study this thing. Impulse, that is force into time interval. So force is a vector quantity, time interval is a scalar quantity. So this product resultantly give you vector quantity. So here impulse, only one vector quantity is there. So answer is impulse. Now 3.2 Pick out the two scalar quantities in the following list: force, angular momentum, work, current, linear momentum, electric field, average velocity, magnetic moment, reaction as per Newton's third law, and relative velocity. So here we have to pick out two scalar quantities, right? So see, the quantities given to you are force, angular momentum, then work. Yes, work, that is a scalar quantity. Then current. Yes, current, that is also a scalar quantity. And all other quantities are vector quantities. So here answer is work and current. Now 3.4 State with reasons whether the following algebraic operations with scalar and vector physical quantities are meaningful or not. A. Adding any two scalars. B. Adding a scalar to a vector of the same dimension. C. Multiplying any vector by any scalar. D. Multiplying any two scalars. E. Adding any two vectors. F. Adding a component of a vector to the same vector. Now see, first one, adding any two scalars. Addition of any two scalars is not possible. Addition of two scalars is possible only for those scalars which have same dimensions. Which have same dimensions. It implies that suppose you want to take the summation like this, 1 kilogram plus 2 kilogram. That is 3 kilogram. Yes, that is possible. But you can't take the summation like this, 1 meter plus 1 kilogram. Not like that. Clear? So, any two scalars? No. You can add two scalars only with same dimensions. Then B. Adding a scalar to a vector of the same dimensions. No. The summation between scalar and vector quantity, that is not possible. Right? Then C. Multiplying any vector by any scalar. Yes, that is possible. And in theory also, we studied one topic in which we discussed the multiplication of vector with any scalar quantity. Right? So that is possible. And see, we have the example force F, that is equal to mass into acceleration. So acceleration is a vector quantity, mass is the scalar quantity, like that. Now multiplying any two scalars. Yes, we can multiply any two scalars. No problem in that one. Then adding any two vectors. Again here the same thing. No. Any two vectors can be added. Only those two vectors can be added which have same dimensions. Which have same dimensions. Clear? F. Adding a component of a vector to the same vector. No, that is not possible, that is not meaningful also. And there is no meaningful algebraic operation in this one. Clear? So this is not possible. Now 3.5. Read each statement below carefully and state with reasons if it is true or false. A. The magnitude of a vector is always a scalar. B. Each component of a vector is always a scalar. C. The total path length is always equal to the magnitude of the displacement vector of a particle. D. The average speed of a particle defined as total path length divided by the time taken to cover the path is either greater or equal to the magnitude of average velocity of the particle over the same interval of time. E. Three vectors not lying in a plane can never add up to give a null vector. Now see, A. The magnitude of a vector is always a scalar. Yes, magnitude of the vector, that is just a mathematical number. So it is always a scalar quantity. Okay. Then B. Each component of a vector is always a scalar. No. Component of a vector, that is a vector quantity always. Right? Then C. The total path length is always equal to the magnitude of the displacement vector of a particle. No. Path length is equal to magnitude of the displacement vector only in the case when the motion of the particle is in a straight line. Otherwise, in all other cases, path length will be greater than the magnitude of displacement. So, here this one is false. Then D. The average speed of the particle defined as total path length divided by the time taken to cover the path is either greater or equal to the magnitude of average velocity of the particle over the same interval of time. Yes, because see, average speed, that is path length upon time interval, and average velocity, that is magnitude of displacement upon time interval. But displacement is always less than or equal to path length, so definitely a magnitude of average velocity will be less than or equal to average speed. So this one is true. Now three vectors not lying in a plane can never add up to give a null vector. Yes, say, suppose we think about the graphical method for the summation of three vectors. Then in that what we do? We take one vector from any point, then take another vector from the head of first one. Clear? And then after take third one from the head of the second one. And in this process, if the head of the third vector lies on the tail of the first vector and the closed loop is formed, then we can say the resultant vector, that is 0, or summation of these three is 0. But if any one that is not in this particular plane, suppose we consider this third one is not in the plane, then if you place this third one at the head of second one, then it will be out of the plane. So closed loop never be formed. So the summation of these three will never give you the null vector. Clear to all of you? Now example 3.6. Establish the following vector inequalities geometrically or otherwise. A. Magnitude of vector A plus B is less than or equal to magnitude of A plus magnitude of B. B. Magnitude of vector A plus B is greater than or equal to magnitude of vector A minus magnitude of vector B. C. Magnitude of vector A minus B is less than or equal to magnitude of vector A plus magnitude of vector B. D. Magnitude of vector A minus B is greater than or equal to magnitude of vector A minus magnitude of vector B. When does the equality sign above apply? Now let's see. First one. Magnitude of vector A plus B is less than or equal to magnitude of A plus magnitude of B. Now in theory, we already studied this thing. Magnitude of vector A plus B, that is equal to under root A square plus B square plus 2AB cos theta, where theta is the angle between A and B. So here first we can consider, if theta is the angle between A and B, then magnitude A plus B is under root A square plus B square plus 2AB cos theta. Now we have to prove this one is less than or equal to A plus B. So let's first find out the maximum value of magnitude A plus B. Because once we find the maximum possible value of this one, then we can say all other values will be less than that one. Okay? Now see here. From this equation, mathematically we can say this thing. If cos theta that is equal to 1, then magnitude A plus B, that will be maximum. Cos theta is 1 means theta that is equal to 0. So here if we take cos theta that is equal to 1, then we can write magnitude A plus B that is equal to under root A square plus B square plus 2AB cos 0 1. So that is under root magnitude A plus B whole square, that is equal to magnitude A plus magnitude B. Now see, the maximum possible value of magnitude A plus B, that is equal to magnitude A plus magnitude B. For theta equal to 0, it implies that for all other values of theta, or we can say in any other case, the magnitude of A plus B, that will be less than magnitude A plus magnitude B. Clear? So here we can see this thing, if theta equal to 0, only in that case the equality sign that is applied, or in all other cases we can say magnitude A plus B is less than or equal to magnitude A plus magnitude B. Clear to all of you? Now second, magnitude A plus B is greater than or equal to magnitude A minus magnitude B. So here we want to prove magnitude A plus B is greater than or equal to magnitude A minus magnitude B. It implies that in this particular case, we have to find what is the minimum possible value of magnitude A plus B. In the same manner, if we consider angle between A and B, that is theta, then we can write the magnitude is under root A square plus B square plus 2AB cos theta. Now here, if we consider cos theta, the least value of it, that is minus 1, then mathematically we can say if we take cos theta, that is minus 1, means theta equal to 180 degree, then magnitude A plus B, that will be minimum 1. So here we can write now magnitude A plus B minimum, that is under root A square plus B square plus 2AB cos 180, that is minus 1. So A square plus B square minus 2AB, but that is equal to under root A minus B whole square. So we can write that is A minus B. Now minimum value of magnitude A plus B, that is magnitude A minus magnitude B. It implies that for any other value of theta, this will be greater than A minus B. And here for the value of theta equal to 180 degree, the equality sign that will be applicable. Clear to all of you? Now see, magnitude A minus B is less than or equal to magnitude A plus magnitude B. Now magnitude A plus B, that you can write magnitude A plus minus B. Okay, so here if we consider the angle between A and B, that is theta, then angle between A and minus B. So if B is here, minus B will be in opposite direction. Angle between A and B, that is theta. Then angle between A and minus B, that is 180 minus theta. So here we can write magnitude A minus B, that is A plus minus B. So that is under root A square plus magnitude minus B square plus 2A magnitude minus B cos angle between A and minus B, that is 180 minus theta. But 180 minus theta, cos 180 minus theta, that is minus cos theta. This magnitude minus B, that is B. So we can write that is equal to under root A square plus B square minus 2AB cos theta. So here now we can write maximum possible value of A minus B. So here maximum possible value, that is when we take theta equal to 180. So when we take theta, that is equal to 180 cos 180 minus 1. So here we can write maximum possible value of magnitude A minus B, that is under root A square plus B square minus 2AB cos 180. Cos 180, that is minus 1, so minus minus plus. So here So this is equal to under root a plus b whole square. So that is magnitude a plus magnitude b. It implies that here we can say this thing for any other value of theta, a minus b, that will be less than magnitude a plus magnitude b. And here we can see this thing for theta equal to 180 degree, the equality sign that is applicable. Clear to all of you? Now magnitude a minus b is greater than or equal to magnitude a minus magnitude b. So here again we can write as per the previous one, the angle between a and minus b, that is 180 minus theta. So we can write magnitude a minus b, that is under root a square plus minus b square plus 2a magnitude minus b cos 180 minus theta. So that is minus cos theta. Now here when we want to prove this one is greater than or equal to, so we have to find first the minimum possible value. So here if we take minimum value for this one, then that is possible for theta equal to 0, because cos 0, that is 1. So here we will get a minus b minimum, that is under root a square plus b square minus 2ab cos 0. So that is under root a minus b whole square. So that is a minus b. It implies that when minimum possible value of magnitude a minus b is magnitude a minus magnitude b, it implies that for any other value of theta here, magnitude a minus b will be greater than magnitude a minus magnitude b. And here the equality sign that is applicable for theta, that is equal to 0. Clear to all of you? Now example 3.7. Given vector a plus vector b plus vector c plus vector d equal to 0, which of the following statements are correct? A. Vector a, b, c and d must each be a null vector. B. The magnitude of vector a plus c equal the magnitude of vector b plus d. C. The magnitude of vector a can never be greater than the sum of the magnitudes of vector b, c and d. D. Vector b plus c must lie in the plane of vector a and d if a and d are not collinear, and in the line of a and d if they are collinear. Okay. Now see, A. Vector a, b, c and d must each be null vector. No, this is not correct one. The summation of these four vectors can be equal to 0 in many other ways also. Okay. So this statement is not correct one. Then B. The magnitude of vector a plus c equal the magnitude of b plus d. Yes, correct one. See here, if we take a plus b plus c plus d equal to 0, then we can write vector a plus c, that is minus vector b plus d. So if we take magnitude on both the side, then magnitude a plus c equal to magnitude b plus d. Okay. Then third one. The magnitude of a can never be greater than the sum of the magnitudes of b, c and d. So that is correct one. Now mathematically you can understand this thing. If a plus b plus c plus d equal to 0, then take this b plus c plus d on right hand side. So a equal to minus b plus c plus d. Take magnitude on both the side. So we can write magnitude a equal to magnitude b plus c plus d. Now fourth one. B plus c must lie in the plane of a and d if a and d are not collinear. Yes. If a and d are not collinear, then b plus c must be in the plane of a and d. Then and then only it is possible to make the summation of all these 4 equal to 0. If B plus D is in any other plane, then the head of B plus C will never lie on tail of A. Clear? Now, and in the line of A and D, they are collinear. Yes. So see here, you can understand this thing. B plus C, that is minus A plus D. So magnitude B plus C equal to magnitude A plus D must lie in the same plane. And if A and D are collinear, then B plus C must lie in the line of A and D. See how? So if your A plus D, that is like this, then B plus C must be in the opposite direction of this one, and if collinear, then and then only the summation of these 4 will be equal to 0. Clear to all of you? 3.8. 3 girls skating on a circular ice ground of radius 200 meter start from a point P on the edge of the ground and reach a point Q diametrically opposite to P, following different paths as shown in the figure. Okay. Now, what is the magnitude of the displacement vector for each? For which girl is this equal to the actual length of path skated? Okay. Now see here, in the figure, easily you can understand this thing. For all these 3 girls, the starting point is P and end point, that is Q. One move on path PAB, another one move on path PBQ, and third one move on path PCQ. Okay. So here, for all these 3 girls, the displacement vector, that is same one. Okay. So displacement of each girl, that is vector PQ. Right. Now magnitude of displacement vector, so P2Q. So here the radius is given to you 200 meter. P2Q, that is the diameter. So magnitude of PQ, that is 2 times radius. So 200 into 2, that is 400 meter. Now for girl B, so girl B here move on the straight path. So for the motion in a straight line, we know this thing. The magnitude of displacement and the path length, actual distance covered, both are same one. Clear? So for girl B, magnitude PQ itself is the path length and distance covered. Clear? Example 3.9. A cyclist travels from center O of a circular park of radius 1 kilometer and reaches point P. After cycling along 1/4 of the circumference along PQ, he returns to the center of the park along QO. If the total time taken is 10 minutes, calculate 1. Net displacement, 2. Average velocity, and 3. Average speed of the cyclist. Now see here. Cyclist start from point O. Move O to P, P to Q, and then Q to O in 10 minutes. So initial and final, both the positions are same one here. So net displacement, that will be equal to 0. First thing. Second, average velocity equal to displacement upon time interval. But displacement, that is 0. So average velocity, that will be also equal to 0. Then average speed, that is path length, or we can say the total distance travelled upon time interval. So total distance travelled, that is O to P radius, then P to Q arc, then Q to O radius, and this distance is covered in 10 minutes. So first convert this 10 minutes in hour. So we can write here total distance covered, that is radius OP arc PQ plus radius OQ. So R arc, that is 2 pi r circumference by 4 because that is fourth part of it, plus R. So substitute the values, pi that is 22 by 7, you will get 25 by 7. Now 10 minutes, so 10 by 60, that is 1 by 6 hour. So we can say now the average speed, that is total distance covered upon time taken. So 25 by 7 kilometer divided by 1 by 6 hour. So if you solve this one, you will get the answer 21.43 kilometer per hour. Clear? Now exercise 3.10. On an open ground, a motorist follows a track that turns to his left by an angle of 60 degree after every 500 meter. Starting from a given turn, specify the displacement of the motorist at the third, sixth and eighth turn. Compare the magnitude of the displacement with the total path length covered by the motorist in each case. Now see here, it is given to you, on an open ground, motorist follow a track that turns to his left by an angle of 60 degree after every 500 meter. So once 500 meter covered, now it will take turn by 60 degree, and then again 500 meter, then again turn by 60 degree. It implies that here we can understand clearly this thing. The motorist will follow the hexagonal path and he will move on the path A, B, C, D, E, F, A. Now, say here, it is given to you, specify the displacement of the motorist at the third, sixth and eighth turn. Now see, here first turn, then second, then third. So, at the end of third turn, we can say he is at D. So, at the third turn, the motorist will be at D. So, displacement, that is AD, and path length, that is AB plus BC plus CD. So, here the displacement AD, so that we can consider as magnitude AD is AP plus PQ plus QD. From the figure easily you can understand this thing. Now AP, so here if we draw the normal from B to this AD, then this angle will be 30, sin 30, 30 that is opposite upon hypotenuse. So opposite, that is hypo into sin 30. So AP, that is this AB is 500 meter because it is given to you after covering each 500 meter. He take left turn by 60 degree. Now see here. So AP, that is 500 sin 30. Now PQ, that is exactly equal to BC. So that is equal to 500. Again QD, that is 500 sin 30. So we can write AB sin 30 plus BC plus CD sin 30. So 500 into half plus 500 plus 500 into half, sin 30, that is half. So path, the displacement, that is 1000 meter, that is 1 kilometer. And now total path length means total distance covered, that is AB plus BC plus CD, that is 500 plus 500 plus 500. So that is 1500 meter. That is 1.5 kilometer. Now at the 6th and 8th turn. So see here, 3rd, 4th, 5th and 6th. So this is the starting point. And at the 6th turn, he will be at the original position. So here, initial and final position, that is the same one. So displacement, that will be equal to 0, and total path length AB plus BC plus CD plus DE plus EF plus FA. So 6 times 500. Now see here, magnitude of displacement, that will be 0, and total path length is 6 times 500, so that is 3000 meter, that is 3 kilometer. Now at the 8th turn, so this one is 6th, 7th, 8th. So at 8th turn, he will be at C. So displacement, that is AC. Okay. Now if we draw a normal from B to AC, suppose that is BR, then this angle is 60, this one is also 60. Clear? So we can say magnitude of displacement AC, that is AR plus RC. So here magnitude AC, that is AR plus RC. Now AR, that is AB, this AB is 500, so this is 60 degree, so this portion is AB sin 60, and this portion is BC sin 60, that is also 500 meter. So we can write 500 sin 60, that is root 3 by 2, plus 500 into root 3 by 2, that is equal to 500 root 3, that is 866 meter. Now total distance traveled, that is 8 times 500, so 8 into 500, that is 4000 meter, that is 4 kilometer. Clear to all of you? 3.11. A passenger arriving in a new town wishes to go from the station to a hotel located 10 km away on a straight road from the station. A dishonest cabman takes him along a circuitous path 23 km long and reaches the hotel in 28 minutes. What is 1. The average speed of the taxi, and 2. The magnitude of average velocity? Are the two equal? Now see, here it is given to you, hotel is located 10 km away. So displacement, that is 10 km, but cabman takes him along a circuitous path 23 km long. It implies that the total distance covered, that is the path length, is 23 km, and time interval, that is 28 minutes, that is given to you. So first we want to calculate average speed, that is path length upon time interval. Now see, time interval, that is 28 minutes, so that is 28 by 60 hour, that is 7 by 15 hour. And here total path length, that is 23 kilometer. So average speed, that is total path length upon time taken, 23 divided by 7 by 15, that is equal to 49.3 kilometer per hour. Now we want to calculate the magnitude of average velocity. So average velocity, that is displacement upon time interval. Displacement, that is 10 kilometer. So magnitude of average velocity, displacement 10 kilometer upon time taken 7 by 15 hour. It will come to 21.43 kilometer per hour. Are the two equal? No, these two are not equal. We can see from the calculations. Clear? Now exercise 3.12. The ceiling of a long hall is 25 meter high. What is the maximum horizontal distance that a ball thrown with a speed of 40 meter per second can go without hitting the ceiling of the hall? Now see, the ceiling of the long hall, that is 25 meter high, and ball can go without hitting the ceiling. It implies that it moves very close to the ceiling. So we can say 25 meter, that is the maximum height, and initial speed, that is also given to you. So h, that is 25 meter, and v0, that is 40 meter per second. And we want to calculate maximum horizontal distance. Maximum horizontal distance, that is nothing but the range of the object. So maximum horizontal distance, that is the range r. Clear? So h equal to v0 square sin square theta by 2g. Here we want to calculate r, but equation of r, that is r equal to v0 square sin 2 theta 0 by g. So here we have to substitute the value of sin 2 theta 0, right? So first, from the given data, we take h equal to v0 square sin square theta by 2g. So here make sin square theta as a subject of equation and calculate the value sin square theta, that is equal to 25 into 2 into g 9.8 upon 40 square. It will come to 0.306. Take square root of this one. So you will get a sin theta, that is 0.554. Now cos theta, that is under root 1 minus sin square theta. So under root 1 minus, substitute this value of sin square theta, and you will get cos theta, that is 0.833. Now let's calculate range. So range r, that is v0 square sin 2 theta by g, but sin 2 theta, that is 2 sin theta cos theta by g. Clear? Now here we can write v0 square 2 sin theta cos theta by g and substitute the values. So 2 v0 square sin theta, that is 0.554, cos theta, that is 0.833 upon g, and solve it, you will get 150.7 meter. Here you can do one thing also. See, if you find out sin theta, that is 0.554, then from the table of natural sine, you can calculate value of theta also here. And once you calculate theta, then after substitute the value of theta here, then take 2 theta, and again find out the value of that sin 2 theta from the table of natural sine, and thereafter also you can carry out the calculations. Clear to all of you? Now exercise 3.30. A cricketer can throw a ball to a maximum horizontal distance of 100 meters. How high above the ground can the cricketer throw the same ball? Now see here, maximum horizontal distance means maximum range is given to you, or maximum is given to you. So here we have the equation for range, that is r equal to v0 square sine 2 theta by g. If sine 2 theta that is 1, then we will get r, that is maximum 1. So here r maximum, that is v0 square by g, and that is given to you 100 meter. Now if the ball is thrown vertically upward, then when it reaches at the maximum height, its final velocity will be 0. So we can use the equation v square minus v0 square equal to 2ad also. So here final velocity 0, acceleration minus g, and the distance covered, that we want h maximum. Okay. Now in equation v square minus v0 square equal to 2ad, substitute all these values. So 0 minus v0 square equal to 2 minus g h maximum. So h maximum will be v0 square by 2g. Now here this v0 square by 2g, that is 100. So substitute here 100, you will get h maximum, that is 50 meter. See here we can use the equation for the maximum height of the projectile. H, that is equal to v0 square sine square theta by 2g also. Now from this equation you can easily understand this thing. If this sine square theta, that is equal to 1, then you will get h, that is h maximum. So h maximum, that will be v0 square by 2g. Again here substitute the value v0 square by g, that is 100. You will get the same answer. Clear to all of you? Point 14. A stone tied to the end of a string 80 cm long is whirled in a horizontal circle with a constant speed. If the stone makes 14 revolutions in 25 seconds, what is the magnitude and direction of acceleration of the stone? So here we can say this thing, stone moves on the circular path having a radius equal to 80 centimeter, and it makes 14 revolutions in 25 seconds. So in 25 seconds, 40 revolutions are completed. Therefore, in 1 second, how many revolutions are completed? From that we can calculate the frequency. Now we want here magnitude and direction of acceleration. So to calculate acceleration for the object moving on the circular path with constant speed, we have to calculate omega, the angular speed. So first we write here r, that is 80 centimeter, that is the radius, nu the frequency, that is 14 by 25 revolution per second. So one revolution, that is 2 pi radian. So here omega, that is 2 pi nu. So 2 into 22 by 7 into 14 by 25, that is 88 by 25 radian per second. Clear? So this is your omega. Now acceleration will be centripetal acceleration, that is towards the center, right? So that is r omega square. So acceleration, that is r omega square, r that is 80, omega that is 88 by 25 whole square. If you solve this one, You will get the answer 991.2 centimeter per second square. And the direction of this acceleration, that will be towards the center because it is a centripetal acceleration. Clear? Now 3.15. An aircraft executes a horizontal loop of radius 1 kilometer with a steady speed of 900 km per hour. Compare its centripetal acceleration with the acceleration due to gravity. So first of all, we have to calculate centripetal acceleration. Centripetal acceleration, that is v square by r. Radius is given to you 1 kilometer, that is 1000 meter. Speed, that is 900 km per hour, so that is 900 into 5 by 18, that is 250 meter per second. So centripetal acceleration is v square by r, v that is 250, so 250 whole square by r, that is 1000, so it will come to 62.5 meter per second square. Now we have to compare centripetal acceleration and acceleration due to gravity. So take the ratio of A and G. So centripetal acceleration upon acceleration due to gravity, 62.5 upon 9.8, that is 6.38. So here we can say this thing, centripetal acceleration is 6.38 times the acceleration due to gravity. Clear to all of you? Exercise 3.16. Read each statement below carefully and state with reasons if it is true or false. A. The net acceleration of a particle in circular motion is always along the radius of the circle towards the center. B. The velocity vector of a particle at a point is always along the tangent to the path of the particle at that point. C. The acceleration vector of a particle in uniform circular motion averaged over one cycle is a null vector. Now see, first statement. The net acceleration of a particle in circular motion is always along the radius of the circle towards the center. This is false. Why? Because in the circular motion, the acceleration is towards the center only if the circular motion, that is with constant speed. If the speed of the circular motion is not constant, then this one is not possible. So this one is false. B. The velocity vector of a particle at a point is always along the tangent to the path of the particle at that point. In theory, we already studied this thing. On any curved path, when the particle is moving, its instantaneous velocity at any point, that is in the tangential direction. So this one is true. Then third one. The acceleration vector of a particle in uniform circular motion averaged over one cycle is a null vector. Yes, because in uniform circular motion, the speed is constant one. So acceleration is always towards the center at any point on the circumference of the circle. So if we consider two diametrically opposite points on the circumference of the circle, then at these 2 points the acceleration vectors are equal in magnitude, opposite in direction. So it will nullify each other. So in this way, overall, here if we take the average over one cycle, then the vector summation of all the acceleration vectors it will come to 0. So this one is true. Clear? So here this one is true. Clear? Now exercise 3.17. The position of a particle is given by r equal to 3t I caret minus 2t squared j caret plus 4k caret meter, where t is in seconds and the coefficients have the proper units for r to be in meters. A. Find the velocity v and acceleration a of the particle. B. What is the magnitude and direction of velocity of the particle at t equal to 2 seconds. Now see, here the position is given to you and we want to find velocity and acceleration. So in theory we already studied this thing, the differentiation of position with respect to time t, that gives you velocity, and then differentiation of velocity with respect to time t gives you acceleration. So take position r, that is 3t I caret minus 2t square j caret plus 4k caret. It is given to you. Now differentiate this equation with respect to time t. So velocity, that is dr by dt, that is d by dt of this position. Now differentiation of t, that is 1, and differentiation of t square, that is 2t. So 3i caret minus here 2 into 2t, that is 4tj caret. 4k caret, that is constant. So differentiation of constant, that is 0. This is velocity. Now differentiation of velocity with respect to time t gives you acceleration. So again differentiate this result. So acceleration, that is dv by dt, d by dt of velocity 3i caret minus 4tj caret, 3i caret, that is constant, so its differentiation, that is 0. For t the differentiation is 1, so your answer, that is minus 4j caret. Now question B. What is the magnitude and direction of velocity of the particle at t equal to 2 seconds? Now we have the equation of velocity, v, that is equal to 3i caret minus 4tj caret. So at t equal to 2 seconds, if you want to find the velocity, then in this equation here you have to substitute t equal to 2 seconds. So v, that is 3i minus 4tj caret. So v, that is 3i caret minus 4, t is equal to 2. This one substituted here. So you will get velocity v, that is equal to 3i caret minus 8j caret. Right? Now we want magnitude and direction. So magnitude of velocity v, that is under root vx square plus vy square. So magnitude of velocity, that is under root vx square plus vy square, that is under root 3 square plus minus 8 square. So you will get the answer 8.54 meter per second. Suppose velocity is making direction theta with respect to x-axis, then we can write tan theta, that is vy by vx. So theta, that is tan inverse vy by vx, vy, that is minus 8, vx, that is 3. So you will get tan inverse minus 2.6667. And if you find out the value of this one from the natural tangent, table of natural tangent, then you will get minus 70 degree with x-axis. Clear to all of you? Now 3.18. A particle starts from the origin at t equal to 0 second with a velocity 10 j caret meter per second and moves in the xy plane with a constant acceleration of 8 I caret plus 2 j caret meter per second square. A. At what time is the x coordinate of the particle 16 meter? What is the y coordinate of the particle at the time? B. what is the speed of the particle at the time. Now see here, particle start from the origin. It implies that initial position r0, that is 0, and initial velocity v0, that is 10 j caret, and acceleration, that is 8 I caret plus 2 j caret meter per second square. This much information is given to you. Now let's start. See, initial velocity and acceleration are given to you. Initial position, that is 0. Now, at what time is the x coordinate of particle is 16 meter, and what is the y coordinate of the particle at that time? It implies that first of all we have to prepare the equation for the position of the particle at any time t. See here. Now we have the equation for the position r, that is equal to r0 plus v0t, but r0 is 0, so no need to write. So v0t plus half at square. v0 10 j caret into t, half a, that is 8 I caret plus 2 j caret into t square. So 10 j caret t plus 4 t square I caret, these two cancel, so t square j caret. Now first write 4 t square I caret, then from these two terms take j caret common, so you can write r, that is equal to 4 t square I caret plus 10t plus t square j caret. Now compare this one with xi plus yj caret. It implies that multiple of I caret, that is x coordinate, and multiple of j caret, that is y coordinate of the position. So x coordinate any time t, that is 4t square, y coordinate at any time t, that is 10t plus t square. Now, at what time x coordinate is 16 meter? So take x equal to 16 and find out the time. So here if you substitute x equal to 16, 4t square equal to 16, so t equal to 2 seconds. Clear? Now at that time what is y coordinate? So substitute this value of t, 2 seconds, in y coordinate. So y, that is equal to 10 into t, so 10 into 2 plus t square, so 1 into 2 square, that is 24 meter. Clear? Now B, what is the speed of the particle at the time? To find out the speed, first of all we have to find the equation of velocity. Okay, so we have position at any time t, that is 4t square I caret plus 10t plus t square j caret. Differentiate this position with respect to time t, you will get velocity. So see here, velocity, that is dr by dt, d by dt of 4t square I caret plus 10t plus t square j caret. Differentiation of t square, that is 2t, 2t into 4, that is 8t I caret. Differentiation of t, that is 1, so 10 plus t square, for that differentiation is 2t into j caret. Now, what is the speed of the particle at that time? So first of all, we have to take velocity at that time. At that time means which time? 2 seconds. So substitute t equal to 2 seconds in this equation. So v equal to 8 into 2, 16 I caret plus 10 plus 2 into 2, that is 4, so 14 j caret. Now speed, that is magnitude of velocity. So v, that is under root vx square plus vy square under root 16 square plus 14 square. Solve it, you will get the answer 21.26 meter per second. Clear to all of you? 3.19. A. if I caret and j caret are unit vectors along x and y axis respectively, then what is the magnitude and direction of I plus j caret and I minus j caret? B. Find the components of A equal to 2i caret plus 3j caret along the direction of vectors I plus j and I minus j caret. Now see here. First we want magnitude and direction of I plus j and I minus j caret. So see here. I caret that is in x direction, j caret that is in y direction. So I plus j caret, that will be this vector OB. Similarly, I caret in x direction minus j caret in negative y direction. So I minus j caret, that is this vector OC. Okay. Now here OB, that is OA plus AB, means I plus j caret. So your OB vector, that is I plus j caret. Its magnitude, so that is under root multiple of I caret square, that is 1 square, multiple of j caret square, that is 1 square. So under root 2. Okay. Now direction of I plus j caret. So here tan alpha, that is opposite upon adjacent, so that is 1 by 1, so tan alpha is 1, so alpha, that is 45 degree, means I plus j caret, that is at 45 degree with respect to x axis. Now OC, that is I minus j caret. So magnitude of I minus j caret, that is under root again 1 square plus 1 square, or we can write minus 1 square, that will give you 1, so that is under root 2. And direction, so tan beta, that is opposite upon adjacent, so tan beta, that is minus 1 upon 1, that is minus 1, so beta, that is minus 45 degree. It implies that I minus j caret, that is at minus 45 degree with respect to x axis. It implies that it is in the fourth quadrant. Now we want components of A equal to 2i plus 3j caret in the direction of I plus j and I minus j. So here suppose I plus j caret, that is vector B, and I minus j caret, that is vector C. So component of A in the direction of B. So we know this thing. Suppose we have any vector A and vector B like this, an angle between these two, that is theta. Then component of A in the direction of B, that is this much. So from figure you can understand this is equal to A cos theta. Now A cos theta, that is the magnitude of this component, it is in the direction of B. So multiply A cos theta by the unit vector which is in the direction of B. So say it is B caret. Say it is B caret. Now B caret, that is vector B upon its magnitude, and multiply and divide this A cos theta by B. So you can write AB cos theta, that is A dot B, dot product between two vectors. Later on we will discuss this thing in detail, but at present just remember it. Upon magnitude B square into vector B. Now A dot B, so vector A, that is 2i plus 3j, dot B, that is I plus j, upon magnitude B square, that is root 2 its square, so you will get 2 here, into vector I plus j caret. Now this dot product in that multiple of I caret will be multiplied, so 2 into 1 then plus 3 into 1 multiples of j caret will be multiplied. So 2 into 1 plus 3 into 1 divided by 2 into I caret plus j caret, so you will get 5 by 2 I caret plus j caret. So here 5 by 2 I caret plus j caret is the component of vector A in the direction of vector B. Now in the same manner, you can find component of A in the direction of C. In the same manner here, you can write A dot C upon magnitude C square into vector C. So A dot C upon magnitude of C square into here vector C. So A, that is 2I caret plus 3j caret dot C I caret minus j caret into vector C I caret minus j caret upon under root 2 square, that is 2. So 2 into 1 plus 3 into minus 1. So 2 into 1 plus 3 into minus 1 by 2 into I caret minus j caret. You will get minus 1 by 2 I caret minus j caret. So we can say this minus 1 by 2 into I caret minus j caret is the component of vector A in the direction of I minus j. Clear to all of you? Now 3.20. For any arbitrary motion in space, which of the following relations are true? A. V average equal to V at T1 plus V at T2 by 2. B. V average equal to R at T2 minus R at T1 upon T2 minus T1. C. V at T equal to V at 0 time plus A T. D. R at T, that is equal to R at 0 plus V at 0 into T plus half A T square. E. A average equal to V at T2 minus V at T1 by T2 minus T1. Now see here. Actually, this equation, and this equation. These three equations we derived in the theory for the motion of a particle with constant, or we can say uniform acceleration. Here it is given to you for any arbitrary motion. So these three equations are not true for any arbitrary motion. These three equations are true only if the acceleration of the particle, that is constant one. Clear? But if we think about this equation and this equation, so our generalized one, as per theory, average velocity, that is change in position upon time interval, and average acceleration, that is change in velocity upon time interval. So we can say this thing here, A, C and D are not true, but B and E are true relations. 3.21. Read each statement below carefully and state with reasons and examples if it is true or false. A scalar quantity is one that A is conserved in a process, B can never take negative values, C must be dimensionless, D does not vary from one point to another in space, E has the same value for observers with different orientation of axis. Now see, a scalar quantity is one that A is conserved in a process. No, this is false. kinetic energy does not conserve in inelastic collision, and kinetic energy, that is a scalar quantity. Clear? Then B, can never take negative values. Okay, that is also wrong. False one. We know this thing, the potential, then temperature, that can take negative values, and potential, temperature are the scalar quantities. Then C, must be dimensionless. Again false. See, the density, kinetic energy, potential, all these physical quantities are scalar quantities and they have the dimensions. Then D, does not vary from one point to another in the space. Again false. We know this thing, the density, the temperature changes in the atmosphere, right? Then E, has the same value for observers with different orientation of axis. Yes, this one is true. Scalar quantity does not change with the orientation of axis. Clear? So this one is true. Clear to all of you? Now 3.22. An aircraft is flying at the height of 3,400 meter above the ground. If the angle subtended at a ground observation point by the aircraft position 10 seconds apart is 30 degree, what is the speed of the aircraft? Now see, in figure we represent the two positions 10 seconds apart for the aeroplane. So see here, A and B are the two positions separated 10 seconds apart. Okay. Now this one is the ground observation point. So these two positions A and B subtend angle 30 degree, that is given to you at the point of observation. So here, if we take the normal bisector of these two positions, which give you height h, then this angle is 15 degree. Suppose this is x. So here, if we find out the distance between A and B, then speed will be distance upon time. So let's calculate x here. Now see, 10, 15 degree, that is opposite upon adjacent. So x by h that is 3400. So x, that is 3400, 10, 15 degree. Now value of 10, 15 degree that we have to take from the table of natural tangent, and it is 0.2679. So x will be 910.86 meter. Now the total distance covered in 10 seconds, that is 2x. So speed of the aircraft, that is 2x by t. So 2 into 910.86 by 10. So that comes to 182.2 meter per second. So now chapter 3 is completed. Clear?